Hey, and welcome back to class 6. This week we're going to look at animation keys and how to set them within Cinema through Python. To demonstrate this, we're going to create a small program that will let us transfer animation from one object to another. But before we can get started with that, we will have to understand how keys work within Cinema. Now, generally, if you set a key for an animation like this, all you do is you just control-click on one of these dots here, or you press this button and then the keys are being set for you. So you're not actually really thinking about what happens underneath. A key is just a key. But as a matter of fact, it's not that simple in Cinema. A key is not just being set at a time frame, but a key is being set on a curve, on a track. And the best way to visualize that is to look at the timeline editor here. And if you go into the key mode, which is the first mode here, you can see it very well by looking at the graph here. First of all, we have the keys, which are these. Then you can see the keys are sitting on a curve, and that curve is within this piece here, which is a track. And the track belongs, each value of a vector has its own track. And, each attribute, like the position, has its own vector. So you have an attribute. You have one or several tracks for each attribute, and then each track has a curve, and on that curve are the keys. Meaning that if you want to set a key, you have to first get the corresponding track. Then once you have the track, you have to get the curve, and once you have the curve, you can then edit or add new keys. Right. So first things first, how do you find a track? Well, let's get rid of this. Well, to get a track, you have to understand another concept within Cinema, which is description IDs. Let's look at the documentation for that. So here we have the description ID documentation. And, well, it's not really telling us too much. Although this is kind of important. The description ID is used to exactly identify a parameter value. And that is really all it is. We've actually been using description IDs without even knowing what they are. Description IDs, well, like it says here, are used to identify a specific parameter with by a numeric value that we will never see, because we are using the aliases that you have been using all the time, the ones that start with c4d in the front. So let's for example have a look at user data. So let's take our cube here. It doesn't really do much. Let's add some user data, and we're just adding a couple of fields. Let's give it data 1, 2, and 3. Okay, so now we have 3 user data fields there. And you remember we have been using those within our script before. Quickly add a script. No, where are we? There we are. So I'll take a user data field there. We use this value together with either the operator or I added them to the cube. So in that case, it's the object of that operator. So get object. And I'm going to print that. Oh, what have I done? Yes, of course. There. So that's the value from that field. So we've been using that a number of times before. Without even knowing, we have been using description IDs, which is this part here in the middle. Actually, both of them. So it's not just the c4d ID user data, it's also the second parameter, which is 3. A description ID can consist of up to 3 values. And you have to think of them as an hierarchy. So the first value will be the first section of, the description ID and the first section of values that we want to access. In our case, that will be the user data. The second one will be the second level, which means within the user data we want to access value number 3, which is this one here. Just like user data, tracks are being identified by a specific description ID as well. So to find the track, we have to pass in to a search function the description ID that we're looking for, and it will return the track if it exists. Let's look at that track itself. That's a track object. And up here in the construction method, you can see how this description ID is being built up. Now here we have the function that will create description IDs for you, which is just called desk ID. And then within a description ID, like I told you, there are several levels of data. You can't just pass in a numeric value. You have to use this function here called desk level, which will create each level for you within the description ID. So we see here the first level that we create is the base object position. And there's also one for rotation and scale. And then as a second parameter, we pass in a type, and then there's a 0. Now, to create that level, we're using the desk level, and that's described here in the documentation. And if you look at the constructor, we see that the first value is the ID, which is like I told you, the position, rotation, scale, and so on, all the parameter that you want to set basically. Then you can optionally pass a data type, which in the case of a positional data or rotation and scale will be a vector. And then you can pass a third parameter that will just leave at 0, and that's fine for most cases. But for most values within Cinema that are required for the animation, you would pass in a vector or a real value. We're going to look at some of those, but for now, let's concentrate on the vector ones. Okay, so back to the track. So we're creating a vector track for the position, and as a second level for the description, we pass in which part of the vector we want to use, and that's going to be vector x, and there's y and z as well. And this one, because it's only one value of your vector, will not have a type vector, but because a vector consists of 3 real values, will have a type of real. These strings here, you don't really have to remember them. I mean, once you have set this up, and that's what we're going to do, by the way, and we're going to set up a simple function later on that you can reuse in every one of your scripts. So you only have to learn it once, really, understand how it works, but you don't have to remember all these types and all these syntaxes. This is a write once, use many times situation. Right, so anyways, this is what's being used to create the track, but that's also being used to find the track, because this description ID, this entire thing here, up to that part here, this thing is a unique identifier for the x value of your position, and that's that track. If there's one for y and z as well, like I said, but this is a unique identifier for that, and by that you can create and find these tracks. So let's give this a try. Okay, so we have here our cube. We already had some keys set here. So let's see. Once again, our object is going to be because remember, op is the tag and not the object itself. So that's our object. And now to find a track, there's a function in here that's called find ctrack. There we go. And that expects exactly that ID that I was telling you about before. And that makes it rather easy to find a track. So we just copy that. And we use find ctrack. Pass in that very long value. And let's see if something comes out. And there we go. There's our track, and it says position X track. And the same works for all the other values here. So let's say you get a track. Now the next step, like I told you, was to get a curve, because each track has curves, and on the curves there are the animation keys. And that's even easier, because there you don't really have to remember any identifiers and stuff. All you have to remember is one single function, which is called getCurve. So on our track, let's see, so we have our track dot get curve, and that should, oh, let's print this. What have we done? Oh. Oh, come on. There we go. So we have track and we get the curve. And the curve related functions are in the documentation as well. And they are right above the track here in c_curve. And you can see here in the curve, there are the functions to add and insert and remove and move and so on keys. Let's have a look at the get value one, because our object already had keys set. So if we want to find out the value on that curve, even if there is no key on that point in time, then we have to just pass in the current time and the frames per second. So let's try this. Back here, we have our curve, and right, Sean. What did I say? Was it? Oh yeah, time and FPS. So this is just, we're just going to use current time. So we've got that time. Okay. And let's see what it tells us. 239, that looks about right, doesn't it? So if we move around here, let's get rid of the other prints because they are confusing. Clean this up. There we go. So you get the current values on that curve. And you notice you even get values where there are no keys. So these keys are really just markers for your curve. But the data that you get when you get values from that curve is derived directly from the curve itself, not from the keys. So now we know how to read data from a curve, but what we really want to do is, of course, write data to the curve and create new keys. And to do that, we use another curve function, which is addKey. And when we add a key, we pass in a time value. And that, of course, means the position on the curve where the new key is supposed to be added. And you see here, we're not passing in a value yet. So what we're doing is we're just kind of reserving a space for our key on the curve. And when we call this function, we are being returned the key, which is a c_key object, and the index. But to actually set the value, another step is needed, and we have to use the key that's being returned for that. And within the key, we can then set the value of that key, and by that changing the curve. And the set value is rather straightforward. You just take the key, tell it the curve you want to use it on, which of course is being the curve that we just received it from, and then we pass in a new real or floating point value. So, right, so let's give this a try. So we take our curve and we add a key at the current time, and let's see what that returns. And let's get rid of this statement as well. Okay, so that returns this dictionary here, consisting of the index and of the key itself. And the one we're interested in is a key, of course. So key is going to be key dict, and within the dictionary we want the key value. Once again, let's print this so we see what's in there. And there's our key object. And now we're going to take that key and set its value on that curve to something, oh, I don't know, 500. Let's see what that does. And you see here we changed our curve. And let's do this again to something like, well, anything really, 400. And you see here this has changed, and well, we're now setting every key here to 400, so we're just staying on the x-axis on 400, and we're also seeing here that new keys are being created. And when we look at the curve, they have the keys, so yeah, so that's a success. And that's how we create keys. Now, to make this a bit more comfortable, what I have done is I've created a small function that is taking care of finding the tracks, and if we need to create them, and also then set the keys. So let's have a look at how we do that. So first let's clean this up again, get rid of all of this, and let's use that track here. So we're looking still for the track on the x value, and currently of course we have tracks here, but let's say we get rid of all of them. And unfortunately you can't see it because it's out of screen here, but under the animation you have, let's say it's, here you can see it. Under animation there's a delete track. And if you do that, that's getting rid of the tracks and all your animations. So be careful with that. If you delete a track, everything is gone. So if I compile this now and call this, and of course I forgot the print statement, print track. Now I get none. So that means there is no track on X. So to create our function, we would use this value, and we say if track is none. That means there is none. We want to create one. And to create a track, that's in here as well. Let's go into the documentation, to the tracks. And you remember this was what we were looking at in the beginning. Let's take the entire thing here. We're just going to create a track this way by using the description and the object that we want to create the track on. And writing that into the track value. So we're creating the track, and not on the op, but on our object here, the cube. So that's just O. And the rest should be fine as it is. Okay. Let's see what this does. So let's print track once here to see what it's like here, and then print it again after this call. There we go. So in the beginning there was nothing. Now we have a track here. Of course, the track is only in the track variable right now. It's not actually in the object because we have created the track, but you can see here there's no track showing up on that dot here. Normally, once you have a new track, it shows up here. The reason for that is that we haven't written the track back into the object. And to do that, we use a function that can be found in the baselist2d object. And within it, there is a track related function here under tracks, and it's called insert track sorted. And yeah, basically that's exactly what it does. You just pass in the track and it's putting the track within the object. So let's do this with our track. So we take our object and we call insert track sorted track. And let's call it again. There we go. Now we have the track. There's no data in the track yet, so it's showing up as yellow instead of red. But it's there, and that's the important part. With the track in our object, we can now continue to get that track's curve. So track get curve. And then on that curve, we can again add a key. Add the current time. And from the returned key, we take the key dictionary value, and that's going to be our key. And on the key, we set a value. And if all goes well, then this should now set a key, and I think it did. And it did. There you go, there's a key. And if we look at our curve here, there we go, there are our keys, all at 100, like I said here. Okay, so now we know how to read and how to write the data directly from the curve and to the curve of an object. So let's use that to create the program that I told in the beginning that will let us transfer position data from one object to another. So let's clean it all up again. Actually, let's clean everything up and delete everything. And we are going to create a null that will just be a carrier for our Python script. Let's clean this up as well. And on our script, we will have a couple user data values. So we're going to have one value for the source object. It's going to be a link to another object. And we're going to have another link to the target. And because I know we are going to use that, I'm going to add a vector for an offset value. And no limitations to that. Alright, so that's a good starting point. Now I have already prepared the script because there was a bit more typing involved. So let me just grab that and copy that in here. And we are going to have a look at what we're doing here. So it's basically the same thing that I did before, only now I have made it a bit cleaner and a bit easier to reuse. So I'm defining a couple of global variables here, which is description values for X, Y, and Z. That's because we are using them a number of times when we are looking for tracks or creating new ones. And it's just so much cleaner to use these short variables instead of these big hulking definitions of description IDs. And really you only need to define them once and they don't change during the script. So this is good to use as a global value. So just like before, I'm defining the base object position for vector X, Y, and Z. It's exactly the same as we did a moment ago. And then I have created a function that I'm going to use to check for the existence of those tracks. And if they don't exist, we're going to create them. So for each track, I'm checking whether they exist. If they don't exist, then we are just creating them based on the same description and inserting them into the object. And I do that for all three. And that's really all there is to that function. And then the more interesting function is this one here. Let's see. There. This one here is the set position key, and that's also very reusable. And it's just making it, again, much easier to set the position. So, just like before, I'm looking for the tracks. and because I'm calling that function usually after calling this function, I can be pretty certain that the tracks already exist, so I'm not double checking that. I just hope that this one here worked. So now I have the tracks. I get each track's curve, and then for each curve I get a key at our current position, and I set the value to a parameter that I pass into that function. So into that function I pass the object, I pass the time as a base time object, and I pass the position as a vector object. And further down I just take the x, y, and z values of those positions. Right, and this is our main function, which is really quickly described. I'm just getting the user data values here from those two link fields and the vector field. And then if both are populated, then we just get the current time, and we get the current frame, which I'm not actually using anymore. I think I used that for testing, so you can basically ignore that. Let's get rid of that. And then we check whether the tracks exist, and if not, create them. And then we're just taking the source key, or the source's position, plus our offset, and passing it into our position key function to be written into the curves of the target at the current time. And this function, of course, you can use to put any value at any point in time into your object. So that's why it's reusable. And let's see whether that's actually working. So let's quickly set up a scene here. So there we have a floor. Let's create a cube somewhere here, doesn't matter. Nope, didn't want to create another cube. Let's create a sphere. Where is it? There. Put it up here. Make that a rigid body in the floor. So that should now be simulated. Yes. Make it a bit bouncier. What's going on here? There. Oh, that's way too much. Okay, it's just so we have some movement. Right, so let's take the sphere as our source object. And we're going to make the offset here 100, just so we have some distance between the two. And let's make the cube the target. And if I press play here, there we go. You can see the cube is now following the sphere. But not only that, the cube now has animation on all its curves here. And if we look at it, there we go. There we have the bounce. So this is really nice if you just want to use. First of all, you can use it to cache or bake your animation, your dynamic animation, which of course you could do with the with Cinema's own baking function as well. But there may be situations where you just need, well, just a position for something else, or where the baking just doesn't work for you. So this can be used to bake positions, but it can also be used to make stuff bounce that normally wouldn't bounce. So you can just use the sphere as a sort of alias, make that bounce, but your other object is actually getting the animation as well. And of course you can use it to just copy animation from one object to another, one-to-one. Or by using the offset, you can modify the data that's being transferred as well. And of course that's not only working for the position, but also for rotation and scale and so on. Right, so that's how you set animation keys when your value is a vector or a real value or any kind of value that you can, any numeric value. Now, it wouldn't be Cinema if there weren't an exception to that rule, where you use the set value to set the value. There are variables like, for example, the visibility tags here. Not tags, the visibility settings in here that you can't set by using set value. There's another function for that. It's called setGEData. And that's also in the C-key object. So where normally you would use the set value to set the floating point value of that key, for some keys you have to use setGEData instead. So to show you this, I have prepared a scene, which is very similar to the examples we looked at in the beginning. So we're just getting the track again, although this time it's a shorter description ID because it only requires one parameter or one level. And we're not getting the position or rotation or any vector type, but instead we're getting the render visibility, which is ID base object visibility render, which you get when you drag this over here. There you go. And you get the same for the editor as well. So we could just change this to editor and then we had the other visibility setting. But let's stick to the render one for now. And you see here where it expects a type of long. Now, if you remember, set value was setting a type of floating point. And because this is expecting long, when we set any kind of value here, we get our track, but we don't get any valid data in here, which is indicated by this staying yellow and not becoming red. And also, of course, the value in here doesn't change to the one we are looking for. So for that reason, there's another function, the setGEData. And that basically lets us set any type of data that we want into that field. So where before we would set floating point, when we now set 1 in here, it's being recognized as an integer or a long. And now, there we go, we have a valid key. And if we were to set it to 2, that's now default. And if I set it to 0, that's now on. And there are some aliases for those numbers, because I find it rather confusing that 0 is on and the 1 is off. You can instead use c4d208 on, which should lead to on, yes, and we have mode off. Yep. And you have mode default. Was it default? Let's see. No, it wasn't. Ah, no, it was not mode default, it was mode undef. And that stands for undefined, which is the default state. And that should now, yes, there we go. So we've got mode on, off, and undef as an alias for 0, 1, and 2. And this is much more intuitive. Right, so what have we learned this class? We have learned how to read data from animation curves and how to change and insert new data into those curves and how to use that to copy data from one object to another. The object that we were, or the small script that we created here with the source and target, that's going to be reused in the following classes, because in those we are going to look at plugins and how to create your own, and I think this makes for a nice training exercise to convert this into a plugin. Right. Once again, I hope to see you next week, and I hope you had some fun and learned something. And I hope to hear from you in the forums. See you then. Bye.